ABCD is a parallelogram. AP and CQ are perpendiculars from the vertical sides A and C on its diagonal BD. Show that triangle APB is congruent to CQD. So we need to show these two triangles APB, that is APB. Let's mark that triangle. APB. We need to show this triangle is congruent to triangle CQD, that is C, Q and D. So we have C, Q, T. Now, since ABCD is a parallelogram, the opposite sides of a parallelogram are equal. So we need to mark the opposite sides equal. So I can mark DC equal to AB. So I take these two triangles and I say DC. I will write DC on this side because it belongs to this triangle here. DC is equal to AB. And the reason? Opposite side of parallelogram. So I got one side. Now some perpendiculars were given to me. It was given to me AP and CQ are perpendicular. That means here my angle is 90 and this angle too is 90. So let me mark that. So I have angle APB is equal to the other angle, that is CQD, equal to 90. And the reason AP and CQ are perpendicular to BD. So we got the perpendicular, we got an A, this one A equal to this another A here. And it's a parallelogram, so I can also mark alternate angles. Now which will be the alternate angles? If you see here 2 will be equal to 3 because these are the alternate angles. So let's mark that. So we have angle ABQ equal to angle CDQ. And the reason? Alternate angles. Or which lines? Of DC parallel to AB. So now the triangles are congruent. Triangle APB is congruent to triangle to CQD, and this is by AAS test. How do I know it is AAS? This is S here, A and A. Two angles one side. So by AAS test the triangles are congruent. In the next part I have to show that AP equal to CQ. Now earlier I have already shown two triangles congruent. I have shown this triangle here. Congruent to triangle Now if these triangles are congruent, their corresponding sides will be equal. So I can say now that AP will be equal to CQ because they are by CP, CT. So let me write that out. So I have AP is equal to CQ. Reason? CP, CT of triangle APB congruent to triangle CQD. Remember, if triangles are congruent, all their parts are equal. Earlier we had already shown this triangle here by AAS test was congruent to this green triangle. So all the sides and all the angles would be equal. And in this case we wanted AP. So by CP, CT, CP, CT, these two will be equal. Before we do the next sum, we need to learn our property. if I have a parallelogram, if I have any quadrilateral, not a parallelogram, any quadrilateral, say A, B, C, D, and in that quadrilateral, if it is given one pair of opposite sides are parallel as well as equal, then I can say that A, B, C, D is a parallelogram. Means AB should be equal to CD and AB should also be parallel to CD. The same side should be parallel as well as equal. Like if I take another example, here if I have say PQRS, and in this PQRS if I have one pair of opposite sides, the same parallel and the same one equal, now I can say that PQRS is a parallelogram because one pair of opposite sides are parallel as well as equal. Now for the 11th sum. In triangle ABC and DF, it is given to us AB is equal to DE and AB is parallel to DE. So let me mark that. AB and DE equal as well as parallel. So there is a parallelogram here, and the parallelogram will be A, B, E, D will be a parallelogram. So I write that AB equal to DE given and AB parallel to DE. This is given. So therefore I will write AB ED is a parallelogram. The reason, when one pair of opposite sides are parallel and equal, the quadrilateral is a parallelogram. So here we got a parallelogram. Let's complete the parallelogram now. So I complete it. So two sides were parallel and equal. So now I can say the other two sides, that is AD and BE, these two are also parallel and equal. So I'll write that now. Therefore AD is parallel to BE and AD is equal to BE. I'll write this equation 1 because the opposite sides of the parallelogram. Next, it is also given BC and EF is parallel and equal. So we mark that BC, here is BC, and EF, we just write it up here. BC equal to EF and BC parallel to EF. So we have, this is parallel as well as equal. So again we must be having a parallelogram, and that parallelogram will be now C, F, E, B will be a parallelogram. Let me complete it. So this green is now a parallelogram. BC parallel to EF, BC equal to EF. This is given. Therefore, BCFE is a parallelogram, and the same reason, one pair of opposite sides are parallel and equal, the quadrilateral is a parallelogram. So we have yet another parallelogram. So now I can say the other two sides, that is CD and BF, are parallel and equal. So I mark that CF parallel to BE and CF equal to BE. Equation 2, opposite sides of a parallelogram. So in the first statement we wrote that AD is parallel and equal to BE, and now in the second statement we have written that CF is parallel and equal to BE. Because ABED was a parallelogram, we got AD parallel to BE, and we also got AD equal to BE. Then we proved yet another parallelogram, and that was BCFE was also a parallelogram, Now we said CF parallel to BE and CF equal to BE. This we had written as equation 1 and this we wrote as equation 2. Now when we compare both these equations, we can now say that AD is parallel to CF and AD is equal to CF from 1 and 2. Let's mark that on the figure. So we got AD parallel to CF and AD equal to CF. That means we have yet another parallelogram, and by now you would have guessed the parallelogram is ACFE. So we write therefore ACFD is a parallelogram. Same reason, if one pair of opposite sides are parallel and equal, it is a parallelogram. Now we need to prove ABC and DF are congruent. We had 3 parallelograms in this figure. One was the yellow one here. If this was a parallelogram, so I can say now that AB is equal to AD. So I'll just mark that up. And I'll erase the rest because I don't need this now. I had a green parallelogram, and that was, we proved that this was parallelogram. So now I can say BC equal to EF, opposite sides of parallelogram. The rest I will erase. Then I had a blue parallelogram, and this was the blue one, which means now AC is equal to DF, and we erase this now. We don't need this part. Now can you see you have got 2 . So what can you say about triangle ABC and DEF? They're congruent by SSS test. So we need to write this. So first we have taken up, we said AB we said was equal to DE, and the reason, opposite sides of parallelogram ABED. Then we said BC was equal to EF, again opposite sides of that green parallelogram, and that was BCFE. And then we had AC was equal to DF, reason, opposite sides of parallelogram ACFD. So triangle ABC congruent to triangle DEF by SSS test. ABCD is the trapezium in which AB is parallel to CD and AD equal to BC. We first have to show angle A equal to angle B. So I have AB, let me mark AB parallel to DC, and then we have AD equal to BC. Here I need to do a construction. So I need to construct, say, CE parallel to AD. So this I'm going to construct CE parallel to AE. So here this I construct parallel. I produce this further and it will meet this point at E. So I need to write that construction. So here's the construction: draw CE parallel to AD and extend AB to intersect CE at E. So in step 1 we're going to spot a parallelogram here. We already know that AE is parallel to DC. So let's write that. AE parallel to DC because parallel sides of trapezium. And I have also constructed AD parallel to CE has been constructed. So I write that too. AD parallel to CE construction. If I got two pairs of parallel sides, I have to have a trapezium. Not a trapezium, a parallelogram. Now who will be my parallelogram? A, D, C, E will be the parallelogram. So A, D, C, E is parallelogram. And I think you can write the reason on your own. Opposite sides are parallel. Now why did I show it is a parallelogram? Because now opposite sides of a parallelogram are equal. So now I'm going to write AD is equal to AE because opposite sides of a parallelogram are equal. So AD equal to CE, reason opposite sides of parallelogram. But it is also given to me that AD is equal to BC. That was given in the beginning. Here, look up here. AD equal to BC. So I write that too. AD equal to BC. And by now you would have guessed that if AD equal to C and AD is also equal to BC, so now I can say that AD, not AD, I can say BC is equal to CE. This I put as equation, say I put this as equation 1 from 1. Now BC equal to C, if sides are equal, angles also must be equal. So I have this angle here equal to this angle here. I will mark these angles as 1 and 2. So angle 1 equal to angle 2. A reason, angles opposite equal sides. This is one part. I think I'll mark this as 2. Now I need two more angles, and that is 3 and 4. Now what can you say about angle 3 and 1? They form a linear pair. So angle 1 plus angle 3, 180, linear pair. Now I can find another 180 here. You know the adjacent angles of a parallelogram will always be supplementary. So I have this angle A plus angle 2, 4 plus 2 will be also 180. And the reason, adjacent angles of parallelogram. Let's go over this again. So we showed that AD was equal to CE because it was a parallelogram, and AD was also equal to BC. It was given. So I had these two angles equal. I had angle 1 equal to angle 2, opposite angles opposite equal sides. Then we got on to some linear pair. Here I had a linear pair. So I said angle 1 plus angle 3 equal to 180. That was a linear pair. And then we went to the properties of a parallelogram. Let me explain this property first. If I have a parallelogram like this, say this is my one angle here, say A, and another angle here, E. In a parallelogram, we know the opposite sides are parallel, so this becomes co-interior angles. A and E become co-interior angles. So I can say A plus E equal to 180. And I'm using the same property out here. Here I have co-interior angles, and those co-interior angles are A and E. So I will write 4 angle 4 plus angle 2 equal to 180, because the adjacent angles of parallelogram. Adjacent angles of parallelogram are co-interior and they are supplementary. So now equating both, I can now write that angle 1 plus angle 3 is 180, which is also equal to 4 plus 2, 180. But 1 was equal to 2, so 1 and 2 I am cancelling. So what remained now? That angle 3 equal to angle 4. Now angle 3 is B and angle 4 is A. So I got B equal to A, or I can write angle A equal to angle B, and I have proved it. So earlier I proved A equal to B, we already proved. Now we have to prove C equal to D. Now here we can see co-interior angles, and what are the co-interior angles? See, I can draw this U. The lines are parallel. So let me write, I have AB parallel to CD. So angle A plus angle D will be 180. Reason, co-interior angles. Then on the other side also I have another pair of co-interior angles. Again AB parallel to DC, and I have my U here. So I can write C and B are co-interior angles. So I have AB again parallel to CD. So angle B plus angle C is 180, and the reason, co-interior angles. Here too let me mark it up. So I marked angle A plus angle D. So now I have A, let me write here now, A plus D was 180 and B plus C was also 180, because they were co-interior. This A and D 180 and B and C also 180. But earlier we already showed that A was equal to B, so A and B will cancel. So I get D equal to C. And we already have proved A equal to C was already proved. So we have D equal to C. So we proved this D equal to C. So this D equal to C, we are going to use it in our next proof. Here we need to prove ABC congruent to BAD. Let me join ABC. So my ABC will be here. This will be my ABC. Draw it thicker. I have to show this triangle ABC is congruent to triangle BAD. Now that is BAD, this triangle. I have to show these two triangles are congruent. Now we have already shown earlier that A equal to B. I showed this A. This was already proved. AD equal to BC was given to us, and we have AB is common. This AB is common. So by SAS test the triangles are congruent. So let's go ahead and write down. So in triangle ABC and triangle BAD, angle A equal to angle B, that was proved. AD equal to BC, given, and AB equal to AB, common. It was common side. So I can write now triangle ABC congruent to triangle BAD by SAS test. This is the S, this is the A, and this is the S by SAS test.